So we have this exponential function. We need to determine its limiting value when x approaches 0. Now clearly, when we substitute the value of x with 0, so we have a raised to the power of 0, which is 1, minus b raised to the power of 0, that is also 1. So we have 0 in the numerator, and sine of 0 is 0, so we have 0 in the denominator as well. So this is giving us a 0 over 0 indeterminate form. So that means we will need to evaluate this limit using some standard definition. So let us begin with the numerator. So we're considering the first term, which is a raised to the power of mx. So we're going to subtract and add 1 to it. Similarly, for the second term, which is b raised to the power of nx, we're going to subtract and add 1 to it, divided by sine kx. Now we have limit x approaching 0, a raised to the power of mx minus 1. Now we're going to take out the plus 1 and write it as a separate term. And similarly, we have b raised to the power of nx minus 1. This will be considered as a single term. And we take out the plus 1, so it's multiplied to a negative. So we have negative 1. So we have whole divided by sine kx. So the plus 1 and negative 1 gets cancelled, leaving us with two terms in the numerator. Now we're going to divide the numerator and the denominator by x. So we have limit x approaching 0. We have a raised to the power of mx minus 1 divided by x. So we have divided each term. So that's a minus each term by x. And we have b raised to the power of nx minus 1 divided by x whole divided by sine kx divided by x. Now what we're going to do is we are going to, in order to be able to apply the definition of limit, so for the first term in the numerator, we will multiply x by m. So that would mean we'll also need to multiply it by m. Similarly, for the second term in the numerator, we multiply the denominator x by n and multiply the entire term by n. And for the denominator, sine kx over x, so we're going to multiply x by k and then multiply it by k. Now we will apply the limits. So we have m multiplied to limit x approaches 0, a raised to the power of mx minus 1 divided by mx minus n times n, m and n being constant here, so we've taken it out of the limit, x approaching 0, b raised to the power of nx minus 1 divided by nx whole divided by k times limit x approaching 0 sine kx over kx. Now we will use the standard definition. So we have m times, so the limit of a raised to the power of mx minus 1 over mx is going to be natural log of a minus n times the natural log of b divided by k, which is equals to natural log of a raised to the power of m minus natural log of b raised to the power of n whole divided by k. And we have natural log of a raised to the power of m divided by b raised to the power of n multiplied over 1 over k. So this is going to be the limiting value of our function. So this will be equals to 1 over k times natural log of a raised to the power of n divided by b raised to the power of n when x approaches 0. Let's go to the next question. So we need to determine the limiting value of this given function when x approaches 0. So we begin by rationalizing the denominator. So that will be limit x approaching 0. So we have 5 raised to the power of x minus 1. Then we're going to multiply it by square root of 4 plus x plus 2. and we're going to multiply this factor root 4 plus x plus 2 to the denominator as well. So we have square root of 4 plus x minus 2 multiplied to square root of 4 plus x plus 2. So that's going to give us limit x approaching 0, 5 raised to the power of x minus 1 multiplied to square root of 4 plus x plus 2 all divided by 4 plus x minus 2 squared. So negative 2 squared will be 4. So we have limit x approaching 0, 5 raised to the power of x minus 1. So we have an x in the denominator. So we'll put it as the denominator of 5 raised to the power of x minus 1 and apply the limits to the second function, which is square root of 4 plus x plus 2. So the definition tells us that the limit of 5 raised to the power of x minus 1 over x is going to be equals to log of 5, and we have square root of 4 plus 0 plus 2. So square root of 4 is going to be 2, so we have 4 log of 5. So this is going to be the limiting value of a given function when x approaches 0. So let us do another problem. So here we have the function x minus 2 divided by log of x minus 1. So this is going to give us a 0 over 0 indeterminate form. So that means we'll need to use some standard definition of limits. So let's begin with the denominator. So we have natural log of x minus 1. So what we can do is we can add 1 and subtract 1 from it. So that will be 1 plus x minus 2. So we have limit x approaching 2, x minus 2 divided by the natural log of 1 plus x minus 2. Now we're going to change x minus 2. So let x minus 2 be equals to y. So that means when x equals to 2 implies y is equals to 0. So now our limit becomes limit y approaching 0. So we have y divided by log of 1 plus y. Now we can divide both numerator and the denominator by y. So we'll have 1 in the numerator. So we have 1 in the numerator, and in the denominator we have log of 1 plus y divided by y, which as per the definition of limits is going to be 1. So we have 1 over 1. So the given function has a limiting value of 1 when x approaches 2. Let's go to the next question. So this is an extension to the previous problem. So instead of a natural log, this time we have log of x minus 1 with the base of a. So first we'll need to change the base of a from to the natural log. So we have log of, so we'll use this definition that log of a to the base of b is natural log of a divided by the natural log of b. So log of x minus 1 divided by to the base of a is going to be equals to natural log of x minus 1 over natural log of a. So when we substitute this, we have limit x approaching 2, x minus 2 divided by natural log of x minus 1 divided by log of a, natural log of a. Now the natural log of a being constant, so we can pull it out of the limit. So where limit x tends to 2, x minus 2 divided by log of x minus 1. Now from the previous question, we found that this limiting value is going to be equals to 1. So we have natural log of a as the limiting value of this particular function when x approaches 2. Let's go to the next problem. So here we have the function, the natural log of 1 plus x cubed all divided by sine cubed x. So we need to find its limiting value when x approaches 1. So what we are going to do here is we're going to divide both numerator and the denominator by x cubed. So we have natural log of 1 plus x cubed. So we're going to divide it by x cubed. And for the denominator, we have sine cube x. So we're going to divide it by x cubed, or we can rewrite it as sine x over x whole cube. Now when we apply the limits to both the numerator and the denominator separately, so the numerator is going to give us 1 and the denominator is going to give us 1 cube. So our final limiting value is 1 when x approaches 0 for the particular function. Let's do another problem. So we have the exponential function 4 raised to the power of x minus 3 raised to the power of x divided by 3 raised to the power of x minus 2 raised to the power of x. So let us begin by first subtracting 1 from 4 raised to the power of x and adding 1 to it. So this will be the first term, minus 3 raised to the power of x. So we're going to subtract and add 1 to it. Similarly for the denominator, we have 3 raised to the power of x minus 1 plus 1 minus 2 raised to the power of x minus 1 plus 1. So that gives us limit x approaching 0, 4 raised to the power of x minus 1 plus 1 minus 3 raised to the power of x minus 1. So negative times plus 1 will be negative 1 divided by 3 raised to the power of x minus 1 plus 1 minus 2 raised to the power of x minus 1 minus 1. Now we can cancel out the 1 and negative 1 from in the numerator as well as in the denominator, and that leaves us with 4 raised to the power of x minus 1 minus 3 raised to the power of x minus 1 divided by 3 raised to the power of x minus 1 minus 2 raised to the power of x minus 1. Now what we will do here is we are going to divide each term by x, and we are going to multiply the entire numerator by x. Similarly for the denominator, we are going to divide each term in the denominator by x and multiply the entire denominator by x, so that we can apply the definition of limit. So this x and x gets cancelled out. Now applying limit to each of the terms in the numerator as well as in the denominator. So we'll have log of 4 minus log of 3 divided by log of 3 minus log of 2. So log of 4 minus log of 3 is going to be log of 4 divided by 3 whole divided by the natural log of 3 divided by 2. So this is by using the property, which is also the limiting value of a given function when x approaches 0. Let's move on to the next question. So here we have the natural log of 1 plus 2x divided by 3 raised to the power of x minus 1. So what we will do is we will divide the numerator by 2x. So we have natural log of 1 plus 2x divided by 2x. So that means we'll also have to multiply the entire numerator by 2x. As for the denominator, we have 3 raised to the power of x minus 1. So we're going to divide it by x and multiply the entire denominator by x. So the x and x, which is a common factor in both the numerator and the denominator, cancels out, leaving us with 2 times the limit of x approaching 0, natural log of 1 plus 2x divided by 2x whole divided by limit x approaching 0, 3 raised to the power of x minus 1 divided by x. So we have 2 times 1 in the numerator divided by natural log of 3 in the denominator. So the limiting value of a given function is 2 over natural log of 3 when x approaches 0. Let's do another problem. So here we have 3 raised to the power of 2 plus x minus 9 divided by x. So let us begin by working with the numerator first. So we have limit x approaching 0. So we have 3 squared times 3 raised to the power of x minus 9 divided by x. So we can take 3 squared, which is 9, as the common factor. So that leaves us with 3 raised to the power of x minus 1 divided by x. 9 being a constant, we can pull it out of the limit. So we have 9 times the limit of 3 raised to the power of x minus 1 when x approaches 0, which by definition is going to be natural log of 3. So 9 log 3 is the limiting value of a given exponential function when x approaches 0. Let's move on to the next question. So here we have the exponential function 8 raised to the power of x minus 2 raised to the power of x all divided by x. So we have limit x approaching 0, 8 raised to the power of x minus 1 plus 1 minus 2 raised to the power of x minus 1 plus 1 all divided by x, which will be equals to limit x approaching 0, 8 raised to the power of x minus 1, so this will be one of the term, plus 1 minus 2 raised to the power of x minus 1 minus 1 will be the other term, so negative 1 and positive 1 gets cancelled, and when we separate the terms we have limit x approaching 0, 8 raised to the power of x minus 1 all divided by x. We're also going to apply the limit to the second term, so we have 2 raised to the power of x minus 1 divided by x, so that gives us natural log of 8 minus natural log of 2. Now using the property, so we have natural log of 8 over 2, which is going to give us natural log of 4, or simply 2 log 2. So this is going to be the limiting value of a given exponential function when x approaches 0. Let's do another one. So here we have another function whose limiting value needs to be determined when x approaches 0. So we have an irrational form in the numerator, so we will need to rationalize it. So let us begin rationalizing the numerator. So we have square root of 1 plus x minus 1. So we are going to multiply it at square root of 1 plus x plus 1, and we need to multiply it to the denominator as well. So we have square root of 1 plus x plus 1 in the denominator. So that is going to give us limit x approaching 0. So we have square root of 1 plus x whole squared minus 1 squared whole divided by natural log of 1 plus x multiplied to square root of 1 plus x plus 1, which will be equals to limit x approaching 0. So we have 1 plus x minus 1 in the numerator, and in the denominator we have natural log of 1 plus x multiplied to square root of 1 plus x plus 1. So the 1 and 1 in the numerator, 1 and negative 1 in the numerator gets cancelled, leaving us with x in the numerator. So we have x divided by the natural log of 1 plus x multiplied to square root of 1 plus x plus 1. Now what we can do, we can divide both numerator and the denominator by x. So that is going to give us limit x approaching 0, 1 over natural log of 1 plus x over x times limit x approaching 0, 1 divided by 1 plus the square root of 1 plus x. Now, as per the definition of limits, the limiting value of log of 1 plus x over x is going to be 1. So we have 1 over 1 multiplied to 1 over 1 plus square root of 1 plus 0. So square root of 1 is 1. So the final limiting value is going to be equals to 1 over 2. So the limiting value of this particular function is half when x approaches 0.